Bismillahirrahmanirrahim. I'm from Department of Chemistry. My name is Hifza Jamshed and I'm doing MS Chemistry from UNT. Now I'm going to review article that is about hydrogenation reactor, multifunctional reactors and continuous state tank reactors. There is content that is about hydrogenation reactors. In this review article, I will present application of carbon nanotube as catalyst port for hydrogenation reactors. And the second one is continuous state reactor. In this reactor, I will discuss review article that is about a 20-liter electrochemical continuous state tank reactors for high rate microbial electrosynthesis of methane from carbon dioxide. And the last one is review article that is about recent development of waste tire derived multifunctional carbonaceous nanomaterials. So first topic is hydrogenation reactors. What is hydrogenation? In hydrogenation reactor, there is a process, there is a chemical reaction that takes place hydrogen and their other compound. And in reactor, different type of chemical reaction take place. Basically, hydrogen reactors is a large pressurized vessel that contain heating element that help in heating, and an agitator. There is an agitator. Agitator is like a machine that help in stirring and mixing. In this reactors, substrate is heated. Which one substrate? Here this substrate means there is unsaturated compound that contain double or triple bond, that is alkene and alkyne, that are converted into saturated forms, saturated derivatives by reduction of hydrogen, and that is heated, and then catalyst is expanded in the substrate. Catalyst that take part in chemical reaction. This is the diagram of hydrogenation reactor. We also can say that this is the fixed bed catalyst reactors. So the first review article that is about application of carbon nanotube as catalyst sports for hydrogenation reactors. First of all, I will tell you about carbon nanotubes. What are carbon nanotubes? That tubes that are made up of carbon and having diameter that is in the range of nanotubes. That has range in the nanoscale. Too much small. Fine. As catalyst that take part in chemical reaction, that is here we will use catalyst that is made up of carbon nanomaterials for the hydrogenation reactions. So what is the purpose of catalyst in any chemical reaction? Catalyst performs their activity in terms of their selectivity, longevity, and also catalyst also help in cost reduction and also energy consumption reduction. So we will use carbon nanotube catalyst that have attraction towards the stability, selectivity, and also interact with the metal spores. So there is introduction that catalysts are essential in production of various chemicals. Hydrogenation catalyst that is serving in different industries like pharmaceutical industries, that is related to medicine and food processing, and also in many other industries. There is heterogeneous catalyst that is preferred for eco-friendly reactions such as hydrogenation, eco-friendly reaction. So hydrogenation reaction is crucial process in organic chemistry that is related to carbon and hydrogen and their derivatives. So it involving metal-based catalysts like platinum, palladium, also tin, lead. So these are metal-based catalysts that we used in carbon nanomaterials. So because because of their stability, and also when they will combine with metal particles, they work effectively. So it will depend on different several factors. For example, the hydrogen partial pressure, this catalyst surface area, and also metal, which type of metal is present, what metal structure has. So what's the temperature of the reaction? So, but these parameters are specifically applied on different compound, not on similarity at one compound. It is not universally applied to all compound. So there is synthesis method of carbon nanotubes. So how we will produce carbon nanotubes? So we can synthesize the carbon nanomaterial on large scale production that is discovered in 1991. Here there is also based on graphitic sheet that are rolled to create in them. With the help of carbon, we can also generate by using catalyst graphite sheets. This production of carbon nanotubes supporting catalyst. Catalysts also rely on carbon nanotubes, that is posting their structure and also creating their method. It's mean they have to work effectively, and also when we use novel metal nanoparticles, so they have to attach to their surface of inner and also outer surface of the carbon nanotubes. So this characterization that engineering aspect of hydrogenation, that which one noble metal catalyst we are using in carbon nanotube synthesis, that is of three-phase reactions will be there. For example, there will be solid, liquid, and also gas in three phases, and the catalyst we are using for that process having is 15 to 400 micrometer. Then we can easily prepare the carbon nanotube with the help of carbon nanotube catalyst for the hydrogen reaction. Which reaction is going on that one reactors? So there is references you can also see there. So my second topic is continuous state tank reactors. There is coolant. Coolant is the diagram of continuous state reactor. As their name shows, there is a continuous training in the reactors. It is continuous trainings that the process equally distributed, and there is also agitator that help in continuously stirring and evenly distributing the product. So there is a reactor fed from where you can add your reactor, and there is a reactor product from where you can get your product. There is coolant inlet and coolant outlet. There is related to temperature dependent. Coolant is typically like a liquid that help in reducing the temperature. So continuous state reactor is a type of chemical reactor that is used in industrial processes to produce chemicals, pharmaceuticals, and other products also. In continuous state reactor are continuously fed into the reactor vessel. This is the reactor vessels. So we will add reactor continuously from there, and when they will mix with the help of agitator and allow them with the other product and produces the desired product that you can get from the bottom. How it will work? Basically, continuous state tank reactor consists of large tank and vessel and made up of stainless steel, which is equipped with steering mechanism. This is their steering mechanism. We can call it agitator. That keep the reactant in motion. Reactant in motion means there is continuous steering, so they are always moving motion. They are always moving. So they are well mixed. The reactant are introduced into that through inlet port, and the product are continuously removed from the outlet port. The key feature of continuous state tank reactor is continuous stirring. As their name shows, there is continuous, so also continuous stirring will happen in this reaction. So its mean reactant are evenly distributed through the vessel, and reaction proceed at the uniform rate. Its mean throughout the process there is same rate, there is uniform rate. So from this, because of this, we can there is control over the reaction condition. For example, temperature, pressure, concentration. We can adjust the by controlling that one factor just because of continuous trading. So continuous trade reactant also require for high conversion rate, and also for continuous mixing that ensure that the reaction will go fast, and in uniform rate. So there is commonly used bioreactors. As a name shows, bio that belongs to living. So there is a reactor that we will use for microorganisms such as bacteria and yeast, which require constant stirring for their activity and optimal growth. So there is all working is written that I have discussed. So there is a review article that is about a 20-liter electrochemical continuous state tank reactor for high rate microbial electrosynthesis of methane from carbon dioxide. Microbial electrosynthesis represent technology for both carbon dioxide utilization and removal of renewable electricity. Here we will use 20-liter electrochemical continuous state tank reactor designed for methane production from gas. With the help of carbon dioxide, we will produce electrochemical synthesis of methane. So electrochemical synthesis, that is tubular electrochemicals and into the continuous state tank reactor. There is the diagram that is about continuous state tank reactor, electrochemical basically. There is tubular electrochemical cell. When there is a continuous state tank reactor, when we put in this one tube into the reactors, that is called electrochemical continuous state reactors. Here we will produce electricity of 20 angstrom. Here we will add carbon dioxide, and there is continuous trading. When there is continuous trading, so with the help of the electricity and carbon dioxide, methane, electrochemical methane will be produced. Reactor size is of 20 liter. There is current density that is about 19.9 angstrom per meter square, and production rate will be of 407.8 and something, and there will be what is the product of what is the percentage of product that will form at the end of methane. So methane will produce 99.4%. There is the Coulombic efficiency. So when we will take when we will produce electricity of 4 angstrom, the reactor is consistently means continuously delivering average methane production rate that is about 375 something liter, and then reached at a maximum rate of 407. So notably, it's mean it will producing product that is about 98%. So 98%. So they if we are giving the current, if we increase the amount of current that is about 16 angstrom, so it has negatively affected the performance of the system due to change in microbial community that is caused by oxygen diffusion across the membrane. So we have to use we also have to keep aware that is about the current. If we will increase the amount of current, then it has negative effect on the concentration and also on the system performance. So microbial electrochemical synthesis, it means this is the technology that we are utilizing for microorganisms. We will use microorganism as a cathodic catalyst to reduce the carbon dioxide into biofuels and biochemicals. So at the end of reactant, microbial electrosynthesis produces different various products such as methane, acetate, ethanol, and so on. So in comparison to abiotic carbon dioxide reduction catalyst, microorganism has different advantages. For example, over potential, greater product selectivity, and also enhance their long chain organic compound. So there is discussion. We have discussed there how multifunctional reactor will work. So impact of current on methane production rate and stability of the reactors. Its mean current has a lot of effects. For example, we have discussed on upper that when we apply the current of 4 angstrom, then continuously in constant amount, inconsistently by electrochemical synthesis, we will produce methane. But when we increase the amount of current, for example, to 6 angstrom, so it will cause negative impact for the system process. So there is written that current has more impact. Current has more effect on the production and also on stability of the reactor for methane production. So there is third reactor that is about multifunctional reactor. As their name shows, there is multifunctional. It means they have to perform different functions. For example, this is a reactor that is multifunctional reactor. In multifunctional reactor, different processes are happening. For example, chromatography, distillation, absorption, stripping, extraction. There is a lot of crystallization. There is a lot of processes are there. They have different functions. So it means when in a single reactor, different processes are going there. So that is multifunctional reactors. So multifunctional reactors are one of the most transport processes and reaction system in a single vessel, resulting mean saving capital and operational cost. It means if there is a reactor, different processes are going there. It will also in a single vessel, so it will also save your time. It will also save your cost. So it has too much advantages for other processes, because a lot of processes are going there. Multifunctional processes also help in intensification by combining the function of chemical reaction. Its mean different processes are occur there uh, just because of their reduction in cost. The basically what is process intensification? Basically, it is a strategy that is reduction in size of chemical plant to achieve a given product. It's mean it is just a small plant, but if we want to we want to take amount in large process, we can take, but there is small plant. So it has advantages in cost reduction and energy conservation. Intensification using multifunctional reactors making chemical plant smaller while still producing same amount of the stuff. It's mean producing small size of chemical plant in order to achieve a given product object. So it started in 1970th century when people wanted to save their money on building plants. Now we are going to be more eco-friendly and competitive. That will also help in cost reduction and also reduce the greenhouse gases. Multifunction reactor are like Swiss Army knives for chemistry. It's mean Swiss knives army means there is like a knife also, sharp blade also, scissor also come in Swiss knives army. So it's mean there is different things, but all have different functions. So it's mean they do many things at one time, but in a single machine. For example, cooling, heating, and mixing. So that's why we call them multifunctional. And also they save money, energy, and also make more better products. So there is different reactors. For example, type A multifunction reactor, it has different function. Type B multifunction reaction that have different function. Here catalyst function will perform. Here interface that is present within the between the reaction system. Here's intra-reactor level that is called type C multifunctionality, that is reactor within the reactor. For example, heat transfer, separation, and that is the last one, that is T-type multifunctionality, that is reactor when we combine the two reactor by using solids. So there is a review article that is about recent developments of waste drive multifunctional carbonaceous nanomaterials. Tire are basically tire are only contact part and force transmission carriers between the vehicle and the pavement. Vehicle and pavement means hard road. So there is also friction when tire on the vehicle will run. So this consists of highly cross polymers in organic fillers that ensure for vehicle safety, comfort, and power. Continuous development of automobile industry tire output is rising, followed by the accumulation of waste. It means we are accumulating the wastage of tire. We are going to recycle that one waste. When tire is waste, this discarded non-biodegradable material and also cause black pollution. It's mean discarded. When we discard the waste of tire, that will also non-biodegradable. Non-biodegradable mean black pollution. It's mean that are harmful for our environment, that is not eco-friendly. We have to make them eco-friendly by using different process, by using carbonaceous materials. Fine. So this has a different environmental pollution, such as it will cause mosquito breeding, disease transmission, and water pollution, and so on. So we have to pay attention toward the disposal of waste tire. So there is black pollution playing. We have to play positive role about that. We have to make our environment eco-friendly. The harmful disposal and effective utilization of waste treatment technology. We have to take some. We have to take some. We have to apply some technologies on that and make economic benefits. So First of all, for recycling, we also have to recycle that one waste tire. So for recycling method, there is recycling method of waste tire, including prototype utilization, retread, reclaimed rubber, incineration, pyrolysis from the prospective material, and energy recovery. What is prototype utilization? We will discuss the all terms in detail. What is prototype utilization? Prototype utilization means using waste tire with the original shape on secondary occasion, means artificial reefs, tunnels, and also in artificial agriculture or so this will extremely lower your cost. So consumption proportion of waste tire is low, that is occupied with the help of potential hazards. In reclaim process, we have to tread the waste tire that is treated by the grinding and cutting the tire and then passing the new rubbers. This technology that is improve the economic value and also material consumption, and there will be price is of 15 to 30%, and that one is that we have recycled and 20 to 50% of new one tire. So, complete frame of waste, tire, and product quality. It's mean if we waste the quality of the product, so consumer also have too much questions that recycle one tire have 50 to 30%. So new one tire have 20 to 50%. So how I will buy that one? That is recycled. So there is too much question arising in consumer's mind. So this reclaimed rubber is obtained by desulfurizing the rubber powder from the base tile, and that is involving if we will desulfurize the rubber from the base tile. So this process is high energy consumption, which means it will be cost effective. So and also will cause acetic gas emissions. It means that one gas is acetic acid that is harmful for human health or harmful for your environment. Also cause that greenhouse gases, too much dangerous gases. So that will cause also land pollution, water pollution. Just because of gases, now gases are also dissolve in your environment. So every pollution it will cause. So that is called black pollution. So due to high rate value of the tires, waste tire are used as solid fuel, and we are also using cement, roasting, power generation, and other fields. Incineration treatment of a waste tire will also cause serious environmental pollution. Incineration means to burn the tire. When we burn the tire, they have serious environmental pollution. It will also produce tail gases that also increase that also cause the environmental pollutions. And we have to use that one method for treatment of waste tire and solve the environmental pollution, and we have to make our environment clean, and we also have to use effective utilization of waste sources. There is pyrolysis technologies. What is pyrolysis technology? First, I will tell you about pyrolysis technology. And basically, what is pyrolysis? Pyrolysis is the thermal decomposition of waste. Which one waste? That is about tire waste. Decomposition of tire waste into gas or solid phase in the absence of external oxygen and air supply. So pyrolysis. It is recognized as environmental friendly for the tire waste, especially for passenger cars, and high temperature treatment of waste tire under anaerobic conditions. That will happen in the absence of oxygen, in the absence of any supply of air. To degrade into three-phase product, for example, solid, liquid, and gases, that is called pyrolytic gases, also called pyrolytic, we can say pyrolytic oil. So, organic component in waste are mostly decomposed into gas and oil through the process of condensation separation processes. So, they produce pyrotic gases that consist of salts in hydrocarbon, in carbon dioxide, hydrogen, sulfur, nitrogen, and many other compounds that have high value as used as a high value as fuel for supply of heat. So we also use that one processes for the waste. So carbon black pyrolysis mostly consist of different type of industrial carbon black due to special performance requirement of different tire product. For example, tire have different parts. There is also rubber present in the tire. So first we have to that carbon black pyrolysis can be used as electrode material for supercapacitors for purification with acid-base method and for activation of potassium hydroxide, then tin transfer of sulfur during the process of the paste tire. So they written that waste tire pyrolysis and carbon black pyrolysis properties. So when we use when we use pyrolysis technologies, it is an efficient process. It will also clean the process that it relies that high utilization rate of waste tire, and also pyrolysis of waste tire will produce 35 to 50% of the solid product, that is about pyrotic carbon black. So in this way, you will produce the carbon black pyrolysis from waste tire that has high content of ash, low distribution, and there is surface activity is lower to the carbon black. So the current carbon black prices is only used for low-grade rubber products such as fuel, and also bring economic benefits and several environmental pollution, and also affect the development of the tire pyrolysis industries. So we can conclude that pyrolysis technologies has effectively treated the waste tire to solve the black pollution. Black pollution has too much hazard for environment and also for human life. It will also cause too much diseases. So we have to realize that carbon resources recovery, and if we will do experiment that carbon black pyrolysis, that is solid phase product from pyrolysis waste of tires, so it will yield 40% of the tire products and having low quality containing high content ash. They will be low content ash, so their particle size also wide and poor surface activity. So in this way we can cycle and reduce the waste tire products. These references written. Thank you so much. That is about my topic.